Simpson Strong-Tie, connecting your house, your home, your life. Making your home stronger, safer. Connectors that make construction faster, easier, and more economical. For dealers, builders, designers, contractors, and homeowners, we connect lives, homes, and people. The strongest ties to a well-connected house.
Hello and welcome. Simpson Strong-Tie leads the industry in product innovation, quality, and technical support for structural connectors. In this short video, we'll cover the basics for correctly installing Simpson Strong-Tie connectors. Effectively utilizing these connectors not only makes construction more efficient, it creates a stronger, safer, well-connected structure. First, making a good connection requires having the right connector. Right connector should be chosen by your architect, engineer, or designer. Our job is to be sure that it is installed correctly. And once the correct connector has been determined, the single most important factor in correct connector installation is the proper use of fasteners. So let's take a look at some of the fastener types you'll be using with Simpson Strong-Tie connectors. Depending on the kind of connector chosen, you may use nails, machine bolts, strong drive screws, or Titan masonry screws. But it's more than just the type of fastener that's important for proper connector installation. So let's look at the most common fastener used with Simpson Strong-Tie connectors, the nail.
There are many different types of nails, so make sure you're using the correct one. Fortunately, most Simpson connectors have the required nail stamped right on the product. But if you're unsure, simply refer to the current Simpson connector catalog. Although two nails may look alike, there are three key features of a nail that will affect the performance of a connector: diameter, length, and finish. The diameter of the nail shank, often referred to as the gauge of the nail, affects the shear capacity of the nail. The thicker the nail, the more shear resistance provided. So be careful. Substituting a nail with a smaller diameter shank will reduce the load capacity of the connection. Here are some common nail types with their associated diameter and wire gauge. The length of the nail is the next most important factor in determining the connector capacity. The reason is simple. Nails must have enough penetration into wood to achieve full shear capacity. Here are some common nail types with their associated lengths. Some connectors require full-length nails and cannot use shorter versions. Examples include hangers with double shear nailing and some heavy top flange hangers like the HGLTV. For other products, substituting a shorter nail will result in drastic load reductions. Never use short nails without first verifying whether they will work. Here are some common nail types with their associated minimum penetration lengths. And keep in mind, when using our patented double shear nail hangers, you must use the specified full-length nails. And finally, consider the finish of the nail. Galvanized or stainless steel nails may be required for corrosion resistance. Check with your local building department for specific code requirements. It's important to realize that many of the nails found in lumber yards are not appropriate for use in connectors. Examples of these nails include drywall or sheetrock nails, roofing nails, and small common nails like the six-penny nail. These nails lack either the length, thickness, steel composition, or coating needed, and they substantially reduce the load capacity of your connectors.
Remember, the incorrect use of fasteners is the single most common mistake made during connector installation. Now that we're aware of the importance of using the right nail for each connector, let's spend some time talking about installing those nails. Metal claw hammer, still the tool of choice.
But palm nailers can also be used and are a great way of reducing installation time when used with the correct bag nails. Some pneumatic nailers can also be used, provided they have nail hole locating mechanisms and they use the correct nail for the connection. Do not overdrive the nails. The nail head should be seated flush with the steel. Keep in mind, though, that most standard framing nailers cannot locate holes and therefore should not be used to install nails into connectors. And furthermore, since most collated nails for standard framing nailers are undersized, they should not be used to install connectors.
Now let's talk about screws. Since screws act differently than nails, they cannot be interchanged.
Screws are often tempered, which makes them brittle, and therefore will not yield the shear strength that nails provide. Examples of common screws not suitable for connectors include drywall screws, deck screws, and lag screws. But Simpson makes a patented screw called the SDS, or strong drive screw, that is code listed, needs no pre-drilling, and comes with the connectors that require them. But beware, do not mistake an SDS screw for a lag screw. A lag screw will not achieve the same loads as an SDS screw and is not allowed with Simpson Strong-Tie connectors. And finally, for those connectors designed for use with masonry screws, remember to pre-drill those holes, the required diameter and depth for correct installation. The drill bit diameter can be found on the packet of screws, and it must be drilled at least 1/2 inch deeper than the screw length.
Now let's talk about machine bolts.
They should of course be pre-drilled to a diameter only 1/16 of an inch larger than the bolt itself, and they require a washer on the wood side of the connection. Carriage bolts, lag screws, and all thread rods cannot be used in place of machine bolts. It's important to remember a pre-drilled hole that's too big for the bolt will compromise the integrity of the wood and make for a weak connection. Since repairs for poorly drilled holes can be costly, make sure the drill bit is of the right diameter, it's not bent, and you drill the hole from one side. Don't try to meet the hole in the middle by drilling from both sides.
You've probably noticed that Simpson Strong-Tie has different shaped holes throughout its product line. You'll see round, oblong, triangular, diamond, and hexagonal shaped holes in our connectors. But what do these different hole shapes mean? Well, each different shape indicates a different fastening requirement.
The most common shape is the round hole. This hole must be filled with the fastener type specified. The only time you may not fill a round hole are for straps and strap type hangers. These products have more holes than are required to allow for multiple fastening capabilities. Oval or oblong holes are simply used to provide easier access in tight locations and should be treated like round holes. As a general rule, all round and oblong holes should be filled with the appropriate nail. Triangle holes are used for increased capacity and must be used if specified by the designer. Connectors that have triangle-shaped holes have a minimum and maximum load value. To achieve the minimum load value, you must fill all round holes. To achieve the maximum load, you must fill all round and all triangular holes. Diamond-shaped holes indicate a temporary fastening option and are there to aid installation. It is not required to fill diamond-shaped holes. Hexagon-shaped holes are used exclusively in conjunction with our Titan masonry screws, and these holes must be pre-drilled.
Along with different hole shapes, Strong-Tie connectors use a variety of innovative design features to help secure their connectors with greater efficiency and more precision. The most common of these are the patented tabs and domes.
Both of these features force the nail at a 45-degree angle, providing correct installation of our double shear nail design and allowing for a much simpler, faster, and stronger hanger installation. Simpson also uses this 45-degree feature with engineered wood product connectors, commonly known as I-joist hangers. This application is referred to as PAN, or positive angle nailing, which actually forces the nail into the wood at a 45-degree angle, minimizing wood splitting problems. Other I-joist hangers feature a bend tab that locks the hanger to the bottom chord of an I-joist, which prevents joist movement and therefore minimizes squeaks in the floor system. Simpson's newest design, the IUS, features a snap-in seat requiring no joist nailing for the fastest possible installation and huge labor savings. Speed prongs are another Strong-Tie innovation found on many of our connectors. Since it can be difficult to hold a connector, hammer, and nail all at the same time, these handy prongs are used to temporarily position and secure the connector for faster, easier installation.
Now that the connectors are installed, it's a good idea to check your work. First, verify that all the appropriate holes have been filled with the specified fasteners.
If this has not been done properly, it could result in a premature failure of the connection, which may create a life-threatening condition. Once you have determined all required holes have been filled, check both parts of the connection to ensure fasteners are installed into appropriate material, like lumber or masonry, and not into thin air.
So let's take a moment to recap what we've learned. First, we know how important it is to verify that we have the right connector for our construction plans. Second, we learned how important it is to use the proper fastener for those connectors. We learned that nails must be the correct length and diameter. And don't forget to check local agencies for any special corrosion considerations.
For screws, we know that Simpson Strong-Tie offers two types of code-listed structurally rated screws, the SDS screw and the Titan masonry screw. The SDS is code-listed as a self-drilling screw, but remember, a lag screw is not an acceptable substitution for an SDS. And because of the base material, it is necessary to pre-drill for proper installation of the Titan masonry screw. We also learned that machine bolts must be pre-drilled to a certain tolerance, and that a carriage bolt or all-thread rod may not be substituted for a machine bolt. In addition to the proper fastener, we know how important it is to use the correct quantity of fasteners. We learned the significance of all the different hole shapes and design features, each representing a different requirement or feature. We learned about innovative features like tabs, domes, pan nailing, and speed prongs, all designed to aid in proper installation. And finally, Simpson Strong-Tie connectors can only be as good as the base material to which they are fastened. Make sure that the material is suitable for fastening and will support the load developed by the connector.
After all, Titans, SDSs, and nails can't work if they're not fastened into adequate material. If you're not sure or it's not stamped directly on the connector, remember, all fastener types and quantities can be found in the current Simpson Strong-Tie catalog or on the web at www.strongtie.com.